Today we're on chapter 10 of the Physics 1 textbook. We're going to be dealing with the idea of the conservation of energy. We want to talk about energy sources, where we get energy, the idea that energy is conserved. We'll talk about usable energy and energy sources. So a lot of different types of energy. There's potential energy, energy that is available and ready to be released but not yet released. Kinetic energy, the energy of things that are moving. Chemical energy, where a chemical reaction will provide some kind of energy for us. Electrical energy, where we have movement of electrons through a circuit that will provide some sort of change for us. Energy conversions, we've got a variety of them. Light energy, for example, can be converted to chemical energy in the process of photosynthesis. Light strikes a leaf. The leaf uses carbon dioxide and water to make carbohydrates and oxygen. The carbohydrates are stored in the leaf as chemical energy for the plant to use. Chemical energy in the form of a battery can produce heat energy and light energy. We run the electrons released by the chemical reaction through a circuit. We heat up a filament, and there's the heat energy, and we also get light energy out of that. And chemical energy can be changed into mechanical energy. We eat food and we store it in our body as chemical energy, and then we go out and run around and play games and do whatever, and we convert that into mechanical energy or energy of motion. Ever been out of energy? A couple of pictures showing people who have just kind of run out. They don't have any more. Where does energy go? We don't lose energy in the universe. There's a law, one of science's basic laws, the law of conservation of energy. Energy is conserved. We do not lose it. It doesn't disappear. It is changed, but it's still around. Energy is converted from one form to another. The examples that we've seen already, where light energy can be converted to chemical energy, or chemical energy can be converted to heat energy. Energy is converted. Here's an example of the conversion of energy, where potential energy is converted to kinetic energy. At the top of the slope, the car has 100% potential energy, has no kinetic energy because it's not moving. As you release the car, the potential energy decreases because the car has less distance to move. The kinetic energy increases because the car is moving. And at the bottom of the slope, there's no more potential energy, but it's all translated into kinetic energy. So we've converted potential energy to kinetic energy in the example. Not all energy is usable. Chemical energy in a battery can be converted to light energy and heat energy. Now, we can't use the light or the heat. We can see it. We use the light to see where we're going, but we can't use it to do anything else. So they are there. They're just scattered where we can't get to them. We can't do anything else with them. Usable energy sources, there are a number of them. Fossil fuels are one. Oil, coal, natural gas, all of these things are found underground, and we have to get them out by extracting them from the earth. Fossil fuels can be used in a variety of ways. You can use them as gasoline for cars and trucks and other vehicles. We can use natural gas to heat our home. That's an increasingly popular way to use energy because it costs less than other forms of energy, and it's pretty clean, non-polluting. Or we can use fossil fuels to burn to generate electricity. We burn the coal or the oil, and that heats water that it goes through turbines that turn generators, and we can create electricity with those. Now, where do we get them? Well, we can get them a variety of ways. We can pump at the oil well. We can pump oil gas out of the ground. We can get coal from underground mining, from strip coal mining. These approaches have some environmental problems with them, particularly strip mining, but this is how we get fossil fuels. Other energy sources are available. One energy source that's available in some parts of the country or some parts of the world is hydroelectric energy. The water is in a dam and it's above the lower level. The water flows through the dam and creates kinetic energy, and then we've converted the potential energy of the water at the start of the dam to kinetic energy. And we can use different resources to generate electric power. We can generate the electricity with hydroelectric power. As I mentioned, the water turns turbines, and that generates electricity. Or we can use wind power, the windmills up on the upper right-hand corner. The wind blows and turns the windmills, and that turns turbines that can create electricity. Or we can generate electricity with solar power, where the sun strikes a solar panel, and that act causes the release of electrons that can be then tapped in for immediate electrical power, or can be stored in batteries for later use. So where have we been? We've converted energy from one form to another. We've talked about conversion of kinetic energy to, or potential energy to kinetic energy. And we've also talked about the conversion of, say, chemical energy to heat energy, or light energy to chemical energy. So energy can be converted from one form to another. Energy is conserved. We don't lose it. We don't have it just disappear from the universe. It may not be in a form that we can use, but it is still conserved. Some energy is present but unusable, and we just can't tap into it. Some energy comes from gas, oil, coal, and we can use that to heat our houses, or we run our cars, or generate electricity. Some energy comes from flowing water, wind, and sun. And these are ways that people are studying to find new sources for energy, because one day we're going to run out of coal and oil and gas. And we need other ways to provide the power that we need to run our lives, to run our homes, to run our businesses. And so a lot of research is being done on studying these other sources of energy. So, hope you enjoyed this. Thanks for being here.